So you throw that in, you get 250.25. Now obviously you can't have 250.25, so you just take it that you need 250 cubes. Therefore need 250 cubes. Always trying to use that previous answer. Next one might look at 6. The third term of a geometric sequence. Geometric sequence. So we know we're using this Tn is equal to a by Rn minus 1. Anytime you're using a sequence, you're using Tn. And if you're using a series or a sum, you're using Sn. So third term of a geometric sequence is 21. Let's change our English into maths. T of 3 is equal to 21. Again, your 3's gone in for your n. So it's a by r 3 minus 1 is equal to 21. A by r squared is equal to 21. AR squared is equal to 21. Not much we can do there. Oh Jesus, it's the second term. Apologies. Having a mare here. 2 minus 1. A to the r. So AR is equal to 21. We'll put a full stop there. We'll probably have to come back to it. The other thing it said, where the hell am I? The third term is minus 63. That's where I got that. T of 3 is equal to minus 63. The 3 went in for your n up here. So a by r 3 minus 1 is equal to minus 63. A by r squared is equal to minus 63. AR squared is equal to minus 63. Now you have two equations. The easiest way probably to do it is get your a on its own and then sub it in up here. So a is equal to 21 over r, and then if you fill that in up there, instead of saying ar squared, you're saying 21 over r times r squared is equal to minus 63. Multiplying fractions, top by top, bottom by bottom. 21r squared over r is equal to minus 63. R into r squared, or just goes r. So 21r is equal to minus 63. R, which is your common ratio, is minus 63 over 21 minus 3. So r is minus 3, and therefore to work out a, back in up here. A is equal to 21 over r. A is equal to 21 over minus 3, which is minus 7. So a is minus 7. What did they ask you for now? Find the common ratio. Common ratio is minus 3, and the first term is minus 7. 8. Sum of the first 200 natural numbers. So in the paper here. Not a problem. So sum of the first 200 natural numbers. So what they mean by a natural number is your positive whole numbers. The sum of them, I'm putting in a plus, and so on, all the way up to 200. Fair enough. So here we can see it's linear or arithmetic because it's got the same first difference of 1. We're not multiplying. So a, my first term, is 1, and d, my common difference, is plus 1. Adding on 1 each time. The sum of a linear sequence, Sn, n over 2, 2a plus n minus 1d. Someone asked, does it matter when you fill in like your 200 for your n? No, you can fill it in at the start or you can fill it in at the end. I generally fill it in at the end, but I alternate. N over 2, 2 times a, 2 times 1 is 2, plus n minus 1, common difference is 1. Sn, n over 2, 2 plus 1, n minus 1, 1 plus n, and then maybe squeeze that together, top by top, n plus n squared over 2. That's my general. So I could work out any amount added together. So if I filled in, if I wanted to check, I could sub in 3. And if I sub in 2, make it easier. First two terms adds up to give me 3. So 2 plus 2 squared is 6. 6 over 2 is 3. We know we're right. So first 200 plus 200 squared over 2. This is the one I had written on the side of my book, but the answer was wrong at the back. 200 plus 200 squared over 2 to 20,100. Oh yeah, looks a wee bit tough. I'll do 10 first because the amount of space I have here. So 10, evaluate the following. Another wee tasty one. Put hairs in your chest like shut like this. 2r plus 1. So remember, this just means the sum of. It's a linear sequence. So the first thing is you must get your a and your d. So get your first three terms. Now remember, this means starting at, sure, starting at r is equal to 3 and your n at here 16. So we're not starting at 1 like it normally is. So your first term is 2 times 3 plus 1, which is 7. Your second term is 2 times 4 plus 1, which is 9. Your third term, 2 plus 5 plus 1, which is 11. You could keep going on, but that's enough because I can see a is 7 and d is plus 2. Now, once I have my first term and my common difference, remember this means sum of, I know I'm using my sum of formula, n over 2, 2a plus n minus 1d. Where's them in? 2 times a tidy her up a wee bit now. 12 plus 2n. You could squeeze them together, top by top, bottom by bottom. And then you can divide in your 2. 2 into 12 goes 6. 2 into 2 goes once. There we go. Now, just be careful on this. What you're doing is you're not subbing in 16 because you're not starting at 1, if you want to think about it. 15 would be if it was at 2. 14 if it's at 3. A lot of people just say 13, but another way, if you wanted to be sure, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Like this is saying, add up all the terms from 3 to 16. And that is how many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're subbing in 14 for our n. So a lot of these probably subbed in 13, or maybe even your 16. But 16 if it starts at 1, 15 if it went from 2, 14 if it went from 3. Just in case, I went all the way up to 160, like you'd be all day writing them out. 6 times 14 plus 14 squared, 280. So if you add it up, the terms from 3 to 16, you get 280. Still okay. Now, 9. And then we're nearly done. The fifth term of an arithmetic sequence is twice a sec. Oh, holy God. The fifth term of an arithmetic sequence. Now, again, no harm to start like this. Arithmetic sequence. So Tn, having a notion what we're going to be doing here, a plus n minus 1d. The fifth term, how do I say that? T5, is twice the second term. Fair enough, the fifth term is twice the second term. In order for them to be equal, you must double that second term. The first whole terms also differ by 9. Now, that might make me work out the common difference. Probably heaps of different ways to do this. The two terms also differ by 9. So here we've got, just imagine we have 5 terms. There's my T1, T2, T3, T4, T5. Now, if I was looking at between the second and the fifth term, which we have there, so there's 1 difference, there's 2 difference, and there's 3 differences. 1 difference from 2 to 3, the second difference between 3 and 4, and the third difference between 4 and 5. Now they're saying the difference between those is 9. So there's 9 of a difference between this term and this term. So 9 divided by 3 is equal to plus 3 is my common difference. I know it's a plus 3 because it's getting bigger. This term 5 is bigger than term 2. So there's a plus 3 of my difference each time. 3, 6, 9. Beautiful. Now, I'll try and work with this a wee bit now. So here, my T of 5, I'm subbing in 5 for my n. Is equal to a plus, 5 went in for my n, 5 minus 1, and my difference there is plus 3. T5 is equal to A plus 4 times 3 is 12. Right, kind of had a wee brick wall, looks odd, but something will come of it. And me T2, so up on me 2 for me N. A plus 2 minus 1, and my common difference is 3. T2 is equal to A plus 1 times 3 is 3. Now they did say T of 5 is equal to twice T of 2. Now T of 5 is equal to that, so I can fill that in. Twice, and T of 2 is equal to that. Now I've got a wee equation. You'll work out A. Six is equal to A, that's my first term. And then find the sum of the first 10 terms. So another wee bit in this. So my first term is 6. Second term is 9, 12, 15, 18. You could keep writing out the first 10 terms and then add them all up. Or you can use that ASM. And it doesn't matter if you solve in 10 for n at the start or at the end. And your A is 6. Common difference is 3. And S at 10. 90 plus 300 to 195. So you could find that out as well by just writing out the 10 terms, adding them up, probably just as quick. Have a wee look, might take time, things not keeping. So the advanced exercises now. We'll look at question 3. So a ball is dropped from a height of 10 meters and bounces back. Now I'm not going to draw the graph. To 6 meters and so on. Copy the graph. Next 5 heights. We'll do the next 5 heights. So it starts off. Imagine a ball's up here. Drop from a height of 10 meters. And then it goes up to 6 meters again. So it bounces up, bounces down 6 meters. Then it bounces up 3.6 meters. Bounces down. And do the next 5 heights. Now it's not a linear sequence. It's not going down 4. If it goes down 4 again, it'll go to 2. So it's going to be a geometric sequence. So we'll get the common ratio. R by dividing T2 over T1 should be the same as T3 over T2. We can check. So 6 over 10, which is 0.6. And is that the same as 3.6 over 6? It is 3/5 or 0.6. So it's geometric. Therefore, to get the next few heights, all you've got to do is multiply this by the common ratio. So the next height here would be 3.6 by the common ratio 0.6. 2.16 meters. So it goes 2.16 up, 2.16 down. And then that there is multiplied by 0.6 to get the next one. 1.296. Now these aren't looking nice now. But I think they're just trying to get the idea it's geometric. Multiply it by 1.6, 0.7776. That by 0.6, 0.466, 0.467 we'll say. What are we at now? 0.2799. Is that 5 of them anyway? 1, 2, 3, 4, 5 it is. Right, so you can draw your wee graph if you like. So write down a series of numbers representing the total distance travelled by the ball. There's a nice one. Total distance. just go through it. Just drop from a height of 10 meters at the start. So say you're up a ladder, drop it down 10 meters, and then I went up 6 meters and down 6 meters, up 3.6 meters, down 3.6 meters, up 2.16, down 2.16, up 2.9, and it keeps going on and on and on. So a series of numbers. There is a tidier way to write that. If you look, there's 2 of each of these. So like this is the initial height from where it was dropped, and I went, as we said, I went up, then I went down that height, up, down, up, down, and so on. So you could simplify that as my initial 10 meters plus we had 2 of each of these, 2 of those, 2 of those, 2 of those, 2 of your 6 plus 3.6 plus 2.16 plus 1.296 and so on. And when you do that, it's almost like your recurrent decimal. This is forming an infinite geometric because it's common ratio, and a series because they're being added on, and it keeps going on and on and on. Yeah, so we've got an infinite geometric series. That's like the recurrent decimal from yesterday. What are we at? 16 minutes. I'll have to finish in this one. Describe what type of series is generated. There we go. Part 2, infinite geometric series. And find the total distance travelled by the ball. So we'll work with our infinite geometric series first of all. And that infinite geometric series always gets my head right if I write the formula, which is a over 1 minus r. A is your first term of that infinite geometric series, which is 6. 1 minus the common ratio, which is up there, 0.6. Throw that in now. Watch this. 15. So that'll peter out to 15 meters for this bit here, and now we've got 10 plus 2 times 15, which is equal to 40 meters. Find the total distance. How is the size of the ball accounted for in this problem? Size of the ball, I don't know, maybe they're on about like it's not losing any energy from each bounce, but that's getting a wee bit fuzzy. And feck it, we'll try that question 5, see if we do another one. I'm rich, aren't they? It's pleased to see you. Oh, this is the chess thing. How much money will you owe? So they're not adding them up, they're just saying how much money is in week 32 and week 64. So you've got terms 1, then as you go to 2 cent, as you go to 4 cent, 18 cent, 16 cent. That allows you to know that it's geometric. That's a geometric sequence, because she's not going to say on the second day she'll give you 3 cent. She's only giving you the 2 cent. The third day she's only giving you the 4 cent, you know. So there are term numbers, second day or whatever. So on a geometric sequence, I'm using this thing Tn because it's sequence a by r n minus 1. A, my first term is 1, my common ratio, second term over the first term, which is 2, or the third term over the second term, 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. We have it. So r is equal to 2, tidy that up. 1 by 2 n minus 1, there's my general one, or someone might want to write it as 2 times n minus 1, because 1 times anything is itself. And then they ask you for week 32, so 2 times 32 minus 1, which is 2 times 31, massive number. Oh Jesus. 2147 48 3648. Now that's cents. They've asked for euro, so to change cents to euro, if you had 100 cents, you have 1 euro, you divide that by 100. 2147 4836.48. Yeah, that's quite big, yeah. 21 million. Odd. So they might write that in scientific notation at the end. I'd leave it like that unless they asked. And then the second one, 64, to sub in 64 for me n, back up here. So 2 times 64 minus 1, 2 times 63, or 2 to the power of 63, sorry, it's going to be even bigger. 9.22 by 10 to the 18 cent. And to get that into euros, just divide by 100, I'll give you 16. 9.22 by 10 to the 16 euro. If they're adding them all up, the previous terms, you use your SN formula for that. Right.